You walk past a flowering tree, breathe in a grain of pollen, and your body reacts as if the neighborhood has been invaded. Your nose runs, your eyes swell. But the pollen is not attacking you. An allergy is a defense system launching real weapons at the wrong target. That can make the modern immune system look like an ancient army with nothing left to fight. Parasites are rarer in many industrialized places, but the machinery built to confront them is still here. There is some truth in that picture. But the full story is more interesting because an allergic response is not simply unused ammunition looking for entertainment. It is a layered alarm system shaped by parasites, venoms, microbes, damaged tissue, and millions of years of negotiation with the organisms living around and inside us. To understand the mistake, start with immunoglobulin E, usually shortened to IgE. IgE is an antibody. In an allergic person, some of it recognizes a particular substance. One example is birch pollen. Another is peanut protein. A third is the dust mite protein DARE-P1. The first encounter may produce no obvious drama. Immune cells sample the substance, signal to helper T cells, and encourage B cells to make IgE against it, that is sensitization. The IgE then attaches to high-affinity receptors on mast cells, long-lived sentinels stationed in tissues such as the skin, airways, and gut. Now the trap is armed. When the substance returns, it can link neighboring IgE molecules together. If that signal is strong enough, the mast cell releases stored chemicals within minutes, including histamine, and begins making other inflammatory messengers. Blood vessels become leakier. Smooth muscle can contract, mucus production rises, other immune cells are summoned. In the right setting, those are useful actions. A damaged surface, extra fluid and mucus can help expel material. Inflammation recruits reinforcements. Contraction in the gut can help move an unwanted passenger toward the exit. Against a harmless food protein or a grain of pollen, the same program creates itching, swelling, wheezing, vomiting, or worse. The response is spectacularly expensive for something that never intended to hurt you. So why keep such a volatile circuit? One important clue is worms. Parasitic worms or helminths are enormous compared with bacteria and viruses. Many are too large to be swallowed by a single immune cell. Mammals therefore use a different style of defense. Mucus, tissue repair, barrier tightening, muscle contraction, eosinophils, mast cells, and type 2 immune signals that can contain, damage, or expel a parasite. IgE is part of that world. Mast cells also contribute to defense against some parasites, bacteria, and venoms. The system that produces an immediate allergic reaction overlaps with systems that detect danger at exposed surfaces. That does not mean hay fever is a parasite response that accidentally found a birch tree. Evolution rarely leaves labels that neat. Allergic machinery may also protect against toxins. Experiments in mice have found that mast cell and IgE responses can improve resistance to certain venoms, although how much that explains human allergy remains uncertain. The safer conclusion is that rapid type 2 immunity was retained because it performed several useful jobs, not because every modern allergy once had a single purpose. And parasites did not merely provoke this system, they learned to manipulate it. Worm that survives for years inside a host benefits from calming the attack around it. Helminths can drive regulatory signals, alter antibody responses, and dampen some forms of inflammation. Human studies do not show one simple rule. Different worms, exposures, ages, and allergic outcomes produce different results. Some infections, including schistosoma and hookworm in particular settings, correlate with less skin test reactivity. Others can increase allergic sensitization or cause allergic symptoms themselves. That messy relationship matters because it changes the popular hygiene story. The original hygiene hypothesis proposed that declining opportunities for childhood infection might help explain rising hay fever. The modern version is not children are too clean. Researchers now focus more on the loss or alteration of diverse microbial exposures early in life. The ordinary bacteria and other organisms from people, animals, soil, food, and the environment that help developing barrier tissues learn when to react and when to tolerate. The immune system is not born with a finished list of enemies. It is calibrated. Microbes at the skin, gut, and airways provide repeated signals. Barrier cells and dendritic cells integrate those signals. Regulatory cells help suppress unnecessary responses. Timing matters, especially in early life when these relationships are being established. Change the microbial community, and you may change the education. Reviews of human cohorts link allergic risk with features of industrialized life that reshape microbial exposure in the microbiome. Farm environments, animals, siblings, birth mode, diet, and antibiotic exposure have all been studied. But they do not form a household recipe, and association is not the same as proof that any one exposure prevents allergy. Not every infection protects, either. Some respiratory viruses are associated with a greater later risk of wheeze and asthma. Germ-free mice often develop exaggerated allergic responses, but results vary with the allergen and the microbes restored. The evidence supports a system influenced by microbial ecology, not a cleanliness dial with healthy at the dirty end. Genetics also changes the threshold. So do the condition of the skin and airway barriers, the dose and route of exposure, pollutants, diet, infections, and chance. Two people can meet the same peanut protein or pollen grain and train very different immune memories. This is why nothing to fight is a useful hook but a bad diagnosis. An allergic immune system is not bored. It is making a classification error. The target is harmless, but the response is assembled from mechanisms that are real, ancient, and sometimes life-saving. At the mild end, that error means a season of tissues, antihistamines, and suspicious glances at trees. At the severe end, widespread mast cell activation can cause anaphylaxis, a rapid reaction involving breathing, circulation, or several organ systems. The speed makes sense for an alarm designed to act before a threat spreads. The cost is that a false alarm can become the emergency. Natural selection could not simply remove the alarm. A slower, quieter surface defense might lose valuable protection against parasites, toxins, or damaged barriers. A hair trigger alarm catches danger early but misfires more often. A restrained system avoids collateral damage but risks reacting too late. Then human environments changed faster than genes could follow. Many people moved indoors, away from soil and animals, into smaller families and altered diets. Sanitation and medicine removed enormous amounts of suffering, while also changing the microbial and parasitic landscape in which immune systems develop. The result is not an army missing a war. It is an old alarm being calibrated in a new building. The sensors still work, the mast cells still stand guard, the IgE still remembers a shape. But sometimes the shape belongs to pollen. Sometimes the ancient system protects you from a genuine threat, and sometimes it sees breakfast, spring air, or a neighbor's cat, and produces the modern allergy of an immune system with nothing real to fight.